Okay, in this video we're going to expand on those complex numbers and those imaginary values. So before we talked about how to add, subtract, and multiply complex numbers, and now we're going to talk about dividing complex numbers. So let us go ahead and discuss the division of complex numbers. But before we talk about the division of complex numbers, we're going to have to discuss a method in which we can divide these. And I recommend first to go into discussing, let's go ahead and discussing something called a complex conjugate. So on a little side note here, the complex conjugate of a complex number. So that sounds like a mouthful, and it is, but all that means is the following. So if a plus bi is a complex number, its complex conjugate is a minus bi. So all you do is negate the coefficient of the imaginary number. So the complex conjugate, just negate the coefficient of the complex number. So before we get into the division, let's go ahead and do some complex conjugate identification examples. So in the following, identify the complex conjugate. So let us go ahead and in part A, let us say we have 3 minus 2i. In part B, 4i plus 5. And part C, let us look at negative 8i. So if you want to pause this and come back, we'll see how you do. So hopefully, after you pause this and you tried this out, you said, okay, I want to identify that complex conjugate. So that complex conjugate of 3 minus 2i will be 3 plus 2i. That complex conjugate of 4i minus 5, remember, negate the coefficient of the imaginary portion, will be negative 4i plus 5. And the complex conjugate of negative 8i is just going to be a value of positive 8i. So that's what we're going to have when we have these complex conjugates. We have the negation of the imaginary portion. So now what I'm going to ask you to do is that I'm going to ask you to FOIL each one of these. So FOIL the complex value and its conjugate together. Do that for each one, and then while you're doing that, while you do that, pause the video and then come back. So hopefully you did that and now you're back. So I'm going to do a little bit faster. So 3 times 3 gives you a value of 9. 3 times a positive 2i gives you a positive 6i. Negative 2i times 3 gives you a minus 6i. And lastly, we're left with negative 2i times positive 2i gives you a value of negative 4i squared. This will give us 9. 6i minus 6i cancel. We're left with negative 4 times I squared, which is negative 1, because I squared equals to negative 1. So we get 9 plus 4, which is a value of 13. So notice the imaginary portion cancel it out and we have a positive value. Let's try this one. 4i times a negative 4i gives you a negative 16i squared. 4i times positive 5 gives you a positive 20i. 5 times negative 4i gives you minus 20i. And then 5 times 5 gives you a value of positive 25. Hopefully you recognize the 20i and the negative 20i cancel, and you're going to be left with negative 16 times I squared, but I squared is equal to negative 1. So we're going to have times negative 1 still plus 25. 16 times negative 1 gives you a positive 16 plus 25. 16 plus 25 gives you a value of 41. And notice you get another positive number. And in our last complex number and its conjugate, you're just going to have negative 64i squared. But negative 64i squared is going to be equal to negative 64 times negative 1 times negative 1, which gives you a value of positive 64. So maybe you start recognizing a pattern here that a complex number times its conjugate always eliminates the complex portion, the imaginary portion, and you remain with a positive value. So a complex number multiplied by its complex conjugate will always, and there's not a lot of absolutes in math, but will always eliminate the imaginary number and a positive real number will remain. So that's one of those interesting characteristics about complex conjugates and complex numbers, is that the imaginary portion when multiplied together will disappear, and you're left with a positive value at the end. And this is the tactic we're going to use in order to divide complex numbers. So let's go back to that division of complex numbers. And there are a couple different ways to tackle this, but I know a way that I like doing the best because it's the easiest for me. So let us say we have an example of 2 plus 3i divided by 4 plus, now let's do 4 minus, and maybe we'll do plus, now we'll do minus 4 minus 5i. So the rule that I recommend using whenever we divide is to multiply the numerator and denominator by the complex conjugate of the denominator. That sounds like a heavy word load, but it is. So hopefully we say, okay, you know what? I have an imaginary portion of my numerator and denominator. I know I would rather have a real portion of my denominator. That just screams to me for some reason. So that's the reason why I know to remember to multiply through by the complex conjugate of the denominator. So if we look at our problem, we have 4 minus 5i in our denominator. The complex conjugate of 4 minus 5i is going to be 4 plus 5i. But whatever we do in our denominator, we're going to have to do in our numerator, because you can only multiply through by a value of 1. You can only multiply through by a value of 1. So now we're going to have to FOIL our numerator and FOIL our denominator. But remember, in our denominator, we expect a positive real number. Our numerator, not so much, because they're not conjugates. They're not conjugates of each other. So let us go ahead and try foiling through. And I'm going to FOIL my answer here in green. So 2 times 4 gives me a value of 8. 2 times 5i gives you a value of 10i. Those are my outers. 3i times 4, which is my inners, so I'm going to get a value of positive 12i. And then 3i times 5i, which are my last, gives me a value of positive 15i squared. This will be all over. 4 times 4 gives me a value of 16. 4 times 5i gives me a value of 20i. Negative 5i times positive 4 gives me a value of negative 20i. And negative 5i times positive 5i, my last, gives me negative 25i squared. So now I can combine similar values. So up on top, I'm going to have an 8 by itself. 10i plus 12i gives me a value of 22i plus 15 times I squared, but I squared is equal to negative 1. And this will be all over. My 20i and my negative 20i cancel, and I have 16 minus 25 times negative 1, because negative 1 is equal to I squared. Continuing this problem through, we will have 8 up on top minus 15, so we're going to have 8 plus, I'll take a step to do that, 22i minus 15, and this will be all over 16 plus 25. 8 minus 15 gives you a value of negative 7, still plus 22i, and this will be all over 16 plus 25, which gives you a value of 41. And this, to me, is an acceptable answer. However, you're going to see most textbooks, and even some of your instructors might just like to split up the real portion and the imaginary portion. So you would have to split this up in such a fashion. So this 41 gets grouped with the negative 7, and this 41 also gets grouped with that positive 22i. So you could write this as negative 7 all over 41 plus 22 all over 41i. So either one of those are acceptable. However, I have been told that this is the more acceptable answer. This is the more simplified answer. It doesn't seem more simplified to me. However, that's apples and oranges. You definitely want to ask your professors just to solidify which way they prefer, if they care at all. If it was me, I do not care. So I hope this gives you a good idea of the different properties that are involved with complex values. Definitely take some time to practice them because they have to give you a different mentality, different thought process because you're working about the real plane and the imaginary plane.